What if the very fabric of the universe is hiding a secret so profound, it could change everything we think we know? Picture this: 85% of the universe's mass is made up of something we can't see, touch, or even detect directly. It's called dark matter, a cosmic ghost that silently shapes galaxies, bends light, and holds the universe together, yet remains utterly invisible to us. It's as if the universe is playing a game of hide and seek, and we're still searching for the rules. Today, we're diving into the 22 galactic riddles of dark matter, questions so baffling, they've stumped the brightest minds in science for decades. Why does dark matter exist? How does it influence the cosmos? And what if solving these riddles could rewrite our understanding of reality itself? This video is your guide through these profound mysteries, each one a piece of the puzzle that could unlock the secrets of the universe. From its invisible grip on galaxies to its role in the birth of the cosmos, we'll explore the clues scientists are piecing together and the theories that could change everything. So, are you ready to step into the unknown and uncover the truth behind the universe's greatest enigma? Let's begin. Imagine standing in a pitch-black room, your eyes straining to see anything at all. But no matter how hard you look, nothing reveals itself. Now, picture this on a cosmic scale, an entire universe filled with a mysterious substance that doesn't emit, absorb, or reflect light. It's completely invisible, yet its presence is undeniable. This is the essence of dark matter, the first and perhaps most perplexing riddle in our quest to understand the cosmos. Dark matter doesn't play by the rules we're used to. It doesn't glow like stars, shimmer like gas clouds, or even cast shadows. But here's the twist: while it refuses to interact with light, its gravitational influence is impossible to ignore. Scientists first caught onto its existence not by seeing it, but by noticing something strange: galaxies spinning faster than they should, and light bending in ways that defied the laws of physics. These anomalies pointed to an invisible force, a cosmic puppeteer tugging at the strings of the universe. So, why does dark matter refuse to interact with light or ordinary matter? That's the heart of this riddle. Some theories suggest it could be made of weakly interacting massive particles, hypothetical particles that barely interact with the world we know. Others propose actions, tiny, almost ghostly particles that could be hiding in plain sight. But despite decades of searching, we've yet to catch these elusive particles in action. It's like playing the ultimate game of cosmic hide and seek, where the hider is invisible, silent, and doesn't even leave footprints. The challenge isn't just finding dark matter, it's understanding why it behaves the way it does. Why does it shun light? Why does it interact so weakly with everything else? These questions keep scientists up at night, and the answers might just change how we see the universe. But this is only the first riddle. As we peel back the layers of this cosmic mystery, the next question looms even larger. What role does dark matter play in shaping the universe itself? Picture this: galaxies spinning at breathtaking speeds, their stars and gas swirling in a cosmic dance. Yet, something doesn't add up. Based on the visible matter alone, these galaxies should fly apart, their stars flung into the void. But they don't. They hold together, bound by an invisible force. This is where dark matter steps in, the cosmic architect silently shaping the universe as we know it. So, how does dark matter keep galaxies and galaxy clusters intact? Think of it as the scaffolding of the cosmos. Without it, the universe would look dramatically different. Observations and computer simulations reveal that dark matter forms a vast, intricate network, a cosmic web of filaments stretching across billions of light years. These filaments act like highways, guiding galaxies into clusters and superclusters, creating the large-scale structure of the universe. Imagine zooming out to see the universe as a whole. What you'd witness isn't random chaos, but a carefully woven tapestry, with galaxies strung along dark matter's invisible threads. This cosmic web is the backbone of the universe, holding everything in place. Without dark matter, galaxies would drift apart, their stars scattered into the void. The universe as we know it would simply unravel. But what's even more fascinating is how scientists study this invisible framework. Using powerful telescopes and simulations, they map the gravitational effects of dark matter, revealing its hidden influence. It's like trying to understand the wind by watching the leaves it moves. You can't see it directly, but its effects are unmistakable. Now, here's a thought to ponder. What would the universe look like without dark matter? Would it be a vast, empty expanse, or would something else take its place? This question brings us closer to understanding just how vital dark matter is to the cosmos. And as we unravel this riddle, another mystery awaits. How is dark matter distributed throughout the universe, and what does its uneven spread tell us about its nature? Imagine looking at a map of the universe, but instead of seeing stars and galaxies scattered evenly, you notice something strange, vast clumps of something invisible, separated by enormous empty spaces. This is the uneven map of dark matter, a cosmic puzzle that challenges our understanding of how the universe is structured. Why does dark matter clump together in some regions while leaving others almost entirely void? The answer lies in the delicate dance of gravity and the conditions of the early universe. In the moments after the Big Bang, tiny fluctuations in density began to ripple through the cosmos. These fluctuations were like seeds, and gravity was the force that nurtured them. Over billions of years, regions with slightly more matter, dark matter included, pulled in more and more material, growing denser. Meanwhile, the emptier regions stayed sparse, creating a cosmic sponge-like structure. Think of it like a kitchen sponge. The dense parts are where dark matter gathers, and the holes are the voids where it's almost absent. This uneven distribution isn't random. It's a direct result of how gravity sculpted the universe from its earliest moments. But how do we even know this uneven map exists? Enter telescopes like the Hubble Space Telescope, which act as cosmic cartographers. By observing how light bends around massive objects, a phenomenon called gravitational lensing, scientists can trace the invisible hand of dark matter. These observations reveal the clumps and voids, painting a picture of a universe shaped by forces we can't see but can clearly detect. It's like mapping a city at night by watching how streetlights bend around unseen obstacles. This third riddle of dark matter, its uneven distribution, leads us to an even deeper mystery. What connects it to dark energy, the force driving the universe's expansion? The answer might lie in the way these two invisible forces shape the cosmos, from the smallest clumps to the largest voids. And as we explore this connection, we'll uncover even more about the hidden architecture of the universe. Are dark matter and dark energy two sides of the same cosmic coin? This is the fourth riddle we're unraveling today, and it's one that takes us to the very heart of the universe's biggest mysteries. On one hand, dark matter is the invisible glue that holds galaxies together. Its gravitational pull binding stars and cosmic structures into the vast web we see. On the other hand, dark energy is the mysterious force driving the universe's accelerated expansion, pushing galaxies apart at an ever-increasing rate. It's as if the cosmos is caught in a never-ending tug of war, one force pulling inward, the other pushing outward, but could these two enigmatic forces be connected? Some scientists believe they might be. Theories like quintessence suggest that dark energy could be a dynamic field, changing over time and potentially interacting with dark matter in ways we don't yet understand. Others explore the idea of modified gravity, where the rules of physics themselves might bend to explain both phenomena. Imagine the universe as a grand stage, with dark matter and dark energy as actors playing opposing roles, yet somehow their performances might be scripted by the same cosmic playwright. This interplay between attraction and repulsion raises profound questions about the fate of the universe. Will dark energies push eventually overcome dark matter's pull, leading to a universe that expands forever into cold, empty darkness? Or could there be a hidden balance we've yet to uncover? As we ponder this cosmic dance, it's clear that understanding the relationship between dark matter and dark energy is key to unlocking the universe's deepest secrets. But the search doesn't stop here. Next, we'll dive into the hunt for dark matter particles themselves, exploring how scientists are working to detect the invisible architects of our cosmic structure. For decades, scientists have been on a relentless quest to uncover the true nature of dark matter, hunting for particles that could solve one of the universe's greatest mysteries. From deep underground laboratories shielded from cosmic noise to the colossal particle colliders that recreate the conditions of the early universe, every tool at our disposal has been deployed in this search. Yet, despite these extraordinary efforts, dark matter particles remain frustratingly elusive. Why is this? Why has something that makes up nearly 85% of the universe's matter content proven so difficult to detect? The answer lies in the very nature of dark matter itself. Unlike ordinary matter, which interacts with light and other forces in ways we can observe, dark matter barely interacts with anything at all. It doesn't emit, absorb, or reflect light, and it passes through ordinary matter as if it weren't even there. Imagine trying to find a ghostly presence that leaves no trace, no footprints, no shadows, no echoes. That's the challenge scientists face. Experiments like the Large Hadron Collider, which smashes particles together at nearly the speed of light, have pushed the boundaries of what we know about the subatomic world. Yet, even here, dark matter has remained hidden, slipping through the cracks of our most advanced detectors. The search has often been compared to looking for a needle in a cosmic haystack, except the needle might not even be made of anything we recognize. It's a hunt that requires not just precision, but also creativity, as scientists continually refine their methods and rethink their assumptions. Could it be that dark matter particles are simply too small or too weakly interacting for our current technology to capture? Or is there something fundamentally different about dark matter that we're still missing? As we grapple with these questions, the next riddle takes us in a surprising direction, exploring whether dark matter might not be a particle at all, but something entirely different. What if the answer lies beyond the realm of particles and forces as we understand them? What if the universe has been hiding its secrets in plain sight, in ways we're only just beginning to imagine? What if dark matter doesn't exist at all? It's a question that flips the script on everything we thought we knew about the cosmos. Instead of searching for invisible particles, some scientists propose that the answer lies not in what's missing, but in how gravity itself might behave differently on cosmic scales. This is the heart of the sixth riddle. Could modified laws of gravity explain the phenomena we've been attributing to dark matter? Enter MIND, or modified Newtonian dynamics, a theory that rewrites the rules of gravity as we understand them. Instead of invoking unseen matter, Min suggests that gravity doesn't follow Newton's laws precisely when dealing with the vast distances and weak forces found in galaxies. Think of it like revising the rulebook of a game. What if the rules we've been playing by aren't universal? Mint has had some notable successes, particularly in predicting the rotation speeds of galaxies without the need for dark matter. It's as if the universe is whispering, maybe you've been looking in the wrong place, but like any bold idea, Mint faces its share of challenges. While it explains certain galactic behaviors well, it struggles to account for larger-scale phenomena, like the way galaxy clusters move or the cosmic microwave background. These gaps have kept the dark matter hypothesis in the running, but they also highlight how much we still have to learn about gravity itself. The debate between dark matter and modified gravity isn't just a scientific tug-of-war, it's a reminder that the universe is full of surprises, and sometimes the answers might lie in rethinking the very foundations of our understanding. As we wrestle with this riddle, it's worth considering what it means for science as a whole. The pursuit of knowledge often requires us to question even the most deeply held assumptions. Whether dark matter exists or gravity plays by different rules, one thing is certain: the cosmos is far more complex and far more fascinating than we ever imagined. And with that, we turn our gaze to the next mystery: the role dark matter may have played in shaping the early universe. Picture the early universe, a seething cauldron of energy and particles, hotter and denser than anything we can imagine. In this primordial chaos, the first seeds of structure were planted, but not by anything we can see. This brings us to the seventh riddle, the Primordial Puzzle. How did dark matter, invisible and mysterious, shape the very first galaxies? Here's the thing: dark matter didn't just sit idly by. It played a crucial role in cooling and clumping ordinary matter, acting like a cosmic scaffolding. Without it, the universe would have been too hot and chaotic for stars and galaxies to form. Imagine trying to build a house in a hurricane. That's what the early universe would have been like without dark matter's stabilizing influence. Scientists have found clues to this cosmic mystery in the cosmic microwave background, the faint afterglow of the Big Bang. Tiny ripples in this ancient light reveal patterns that point directly to dark matter's presence. It's like finding fingerprints on a cosmic crime scene, evidence of an unseen force at work. Think of dark matter as a cosmic seed. Just as a tiny acorn grows into a mighty oak, dark matter's gravitational pull gathered gas and dust into dense pockets, giving rise to the first galaxies. These galaxies, in turn, became the building blocks of the universe we see today. But the story doesn't end there. As we peel back the layers of this riddle, we're left wondering, could dark matter be connected to another cosmic enigma, black holes? That's where our journey takes us next. Picture this: a supermassive black hole, a gravitational titan, sitting at the heart of a galaxy, devouring everything in its path. Its immense pull is so strong that not even light can escape. But here's the twist: what if this cosmic monster has a secret partner in crime? Enter the eighth riddle of dark matter. Could dark matter be fueling black holes, or even shaping their existence? It's a question that's as fascinating as it is perplexing. Some theories suggest that dark matter, that mysterious, invisible substance making up most of the universe's mass, could collapse under its own gravity to form primordial black holes. These wouldn't be the black holes born from dying stars, but ones that emerged in the earliest moments of the universe, long before stars even existed. Imagine them as ancient relics, hidden in the cosmic shadows, their presence only hinted at by the gravitational ripples they create. But detecting these elusive objects is no easy task. Unlike their stellar counterparts, primordial black holes could be as small as an atom or as massive as a planet, making them incredibly hard to spot. And yet, if they exist, they could solve some of the biggest mysteries in cosmology, from the nature of dark matter to the formation of galaxies. Think of them as the universe's unseen architects, quietly shaping the cosmos from behind the scenes. To put it another way, dark matter and black holes could be like a cosmic engine, with dark matter acting as the fuel that powers these gravitational behemoths. Without it, black holes might not grow to the staggering sizes we observe today, and galaxies might never have formed in the way they did. It's a delicate dance of gravity and mystery, one that scientists are only beginning to unravel. So, what does this mean for our understanding of the universe? If dark matter is indeed connected to black holes, it could reshape everything we know about how galaxies form and evolve. But as we ponder this cosmic puzzle, another question arises. What role does dark matter play in the way galaxies spin? That's where our next riddle takes us, deeper into the heart of the universe's most enduring mysteries. Galaxies are like cosmic carousels, spinning with a grace that defies our expectations. But here's the mystery: they're spinning far faster than they should. According to the laws of gravity, as we understand them, the outer edges of galaxies should move more slowly, like a child at the edge of a merry-go-round. Yet, astronomers have observed that stars on the outskirts of galaxies are whipping around just as fast as those near the center. It's as if there's an invisible force at play, pulling strings we can't see. This is the ninth riddle of dark matter. Why do galaxies spin as if they contain far more mass than we can actually observe? The answer lies in the unseen. Dark matter, that elusive substance, provides the missing mass needed to explain these bizarre rotation curves. Without it, galaxies would simply fly apart under their own speed. Think of it like this: if a carousel were spinning too fast, the children on the outer edge would be flung off unless something, like an invisible hand, held them in place. That's the role dark matter plays, acting as the cosmic glue that keeps galaxies intact despite their rapid motion. This groundbreaking discovery owes much to the work of Vera Rubin, a trailblazing astronomer who meticulously measured the rotation speeds of galaxies in the 1970s. Her observations revealed a startling pattern. Stars on the outer edges of galaxies were moving just as fast as those near the core, a phenomenon that couldn't be explained by visible matter alone. Rubin's work became a cornerstone of modern astrophysics, shining a light on the hidden influence of dark matter, but the mystery doesn't end there. If dark matter is the key to understanding galactic spin, what else might it explain? Could it hold the secrets to time itself? Stay tuned as we dive into the next riddle, where we'll explore how dark matter might shape the very fabric of the universe. What if the very fabric of time itself is shaped by something invisible? Could dark matter, the mysterious substance that makes up so much of our universe, actually influence how time flows? This is the heart of the 10th riddle, a question that challenges not just what we know about dark matter, but how we understand time itself. According to Einstein's theory of relativity, space-time is a dynamic entity, bending and stretching under the influence of mass and energy. But what if dark matter, which doesn't interact with light or ordinary matter, still manages to interact with space-time in ways we've yet to uncover? Some theories suggest that dark matter could create ripples in space-time, warping time or even opening up entirely new dimensions that resemble time. Imagine a cosmic clock, ticking away the seconds, minutes, and hours of the universe. Now picture that clock running faster in some regions, where dark matter is denser and slower in others. This isn't science fiction. It's a real possibility that could reshape our understanding of both relativity and quantum mechanics. If dark matter can alter the flow of time, it might hold the key to reconciling these two fundamental theories of physics, which have remained stubbornly separate for over a century. The implications are staggering. If dark matter affects time, it could mean that entire regions of the universe experience time differently, perhaps even in ways that defy our human perception. Could this explain some of the strange phenomena we observe in deep space, like the uneven distribution of galaxies or the mysterious behavior of black holes? And what would this mean for our own perception of time here on Earth? While these questions remain unanswered, they remind us just how much we still have to learn about the universe and its hidden forces. As we continue to explore the mysteries of dark matter, we may find that time itself is far more flexible and interconnected than we ever imagined. And speaking of connections, this leads us to the next riddle, one that asks an even more profound question. Could dark matter be linked to the origins of life itself? Picture the universe as a vast garden, where the seeds of life are scattered across countless planets. But what if the very soil of this garden, the invisible, mysterious dark matter, holds the key to whether those seeds sprout or wither? This brings us to the 11th riddle, the life connection. Could dark matter's gravitational influence shape the formation of habitable worlds, making it not just a cosmic spectator, but a silent architect of life itself? Dark matter's gravitational pull doesn't just hold galaxies together, it may also sculpt the environments where planets form. Without its unseen presence, galaxies might spin apart, and planetary systems could never coalesce. But here's the twist. What if dark matter does more than just provide stability? What if its subtle gravitational nudges guide the formation of planets in just the right orbits, creating the Goldilocks zones where life can thrive? It's a tantalizing thought. Dark matter as the cosmic gardener, tending to the conditions that allow life to take root. Now, let's go deeper. Some scientists speculate that dark matter could influence the very chemistry of planets. Imagine its gravitational fields subtly altering the distribution of elements, or even shielding nascent worlds from harmful radiation. Could it be that dark matter doesn't just create the stage for life, but also helps write the script? This idea blurs the line between physics and philosophy, inviting us to ponder whether the universe is designed, or at least fine-tuned, for life. And then there's the bigger picture. If dark matter plays a role in shaping galaxies and planets, what does that mean for our understanding of existence? Are we living in a universe where unseen forces quietly guide the fate of stars, planets, and perhaps even life itself? It's a humbling reminder that the cosmos is far more interconnected than we often realize. As we unravel this riddle, one thing becomes clear: dark matter isn't just a scientific curiosity, it's a cosmic puzzle with profound implications for life as we know it. And speaking of puzzles, the next riddle takes us even further into the unknown, exploring dark matter's potential role in the multiverse. Could it be the thread that ties countless universes together? Stay tuned as we venture into even deeper mysteries. Could dark matter be a bridge to other universes? It's a question that sounds like science fiction, but some of the most cutting-edge theories in physics suggest it might not be so far-fetched. This brings us to our 12th riddle. Does dark matter hold the key to uncovering parallel universes or even higher dimensions we can't yet perceive? Imagine the universe as a vast cosmic doorway, On our side, we see the familiar world of stars, galaxies, and planets. But what if dark matter is the faint glow seeping through from the other side, a clue that something lies beyond? Theories like string theory and brain cosmology propose exactly that. These ideas suggest that dark matter could be a remnant of other dimensions, a kind of cosmic echo left behind by universes we can't directly observe. In this view, dark matter isn't just an invisible force holding galaxies together. It might be the fingerprint of a multiverse. But how do we test such an extraordinary idea? That's the challenge. The very nature of these theories makes them incredibly difficult to verify with current technology. We're essentially trying to detect the undetectable, a universe or dimension that exists just out of reach. Some researchers propose that subtle anomalies in the way dark matter interacts with gravity or other forces could provide clues. Others look to the faint ripples in the cosmic microwave background, the afterglow of the Big Bang, for hints of these hidden realms. Yet, despite the hurdles, the possibility remains tantalizing. Think of it like this: if dark matter is a doorway, then we're still fumbling for the key. But every discovery, every new piece of the puzzle, brings us closer to unlocking the secrets of the cosmos. And as we move forward, we're left to wonder what lies on the other side. This leads us to the next riddle, where we'll explore how dark matter not only connects us to other universes, but might also play a pivotal role in shaping the evolution of our own. Over billions of years, the universe has transformed from a hot, dense soup of particles into the vast, intricate cosmos we see today. But this cosmic evolution wasn't a solo act. Dark matter played a crucial role behind the scenes. It's like the invisible architect of the universe, quietly shaping everything from the tiniest galaxies to the grandest cosmic webs. So, here's the riddle: how has dark matter guided this incredible journey of evolution? From the very beginning, dark matter set the stage. In the early universe, tiny fluctuations in its distribution acted as seeds for the formation of stars and galaxies. Without these subtle ripples, gravity wouldn't have had anything to grab onto, and the cosmos might have remained a featureless expanse. Over time, dark matter's gravitational pull drew ordinary matter together, creating the first stars, then galaxies, and eventually the sprawling cosmic structures we observe today. It's almost as if dark matter was the cosmic sculptor, chiseling the universe into existence. But its role didn't stop there. As the universe expanded, dark matter's influence shifted. In the early days, it dominated the gravitational landscape, steering the formation of large-scale structures. Today, it continues to hold galaxies together, preventing them from flying apart as they spin. Yet, dark matter's grip is loosening in some ways. As the universe grows larger and emptier, its effects are becoming more subtle, like a fading echo of its earlier power. This raises an intriguing question: what happens next? If dark matter has been the driving force behind the universe's evolution, could it also hold the key to its ultimate fate? The next riddle dives into this profound mystery, exploring how dark matter might shape the destiny of the cosmos itself. Picture this: the universe as a grand cosmic clock, its hands inching forward toward an unknown destiny. Will it wind down into the chilling silence of heat death, where stars burn out and galaxies fade into darkness? Or will it collapse back in on itself, culminating in a fiery Big Crunch? The answer to this profound question lies in the mysterious interplay between dark matter and dark energy, two invisible forces shaping the fate of everything we know. Dark matter, the gravitational backbone of the cosmos, tugs at the fabric of space, pulling galaxies together. Yet, dark energy pushes back, driving the universe apart at an accelerating pace. This cosmic tug of war determines whether the universe will expand forever, collapse upon itself, or reach some other fate entirely. But how does dark matter fit into this equation? Its gravitational influence could either slow the expansion, tipping the scales toward a big crunch, or act as a counterbalance to dark energy's relentless push. The riddle of the cosmic fate hinges on understanding this delicate dance. As we ponder this question, we're reminded of how much remains unknown, and just as we're left wondering about the universe's ultimate destiny, another mystery emerges. Could dark matter hold the key to unlocking the secrets of quantum mechanics? The next riddle takes us even deeper into the unseen realms of the cosmos. Now, let's step into the bizarre and unpredictable realm of quantum mechanics, where particles don't follow the rules we're used to in the everyday world. Here, particles can exist in multiple states at once, disappear and reappear in different places, or even be entangled across vast distances. It's a place where the laws of physics seem to bend and twist in ways that defy intuition. But what if this strange quantum world holds the key to understanding dark matter? Could dark matter, that elusive substance shaping the cosmos, have quantum properties we haven't even begun to grasp? Some scientists think so. They've proposed theories suggesting dark matter might interact with quantum fields or particles in ways we've never observed. Imagine dark matter as a kind of cosmic ghost, not only invisible to our telescopes, but also playing by rules we can't yet comprehend. It might be entangled with other particles, or perhaps it exists in a quantum state that allows it to interact with the universe in subtle, almost imperceptible ways. The challenge is that quantum mechanics and cosmology, the study of the universe on the largest scales, don't always see eye to eye. Quantum mechanics thrives on uncertainty and unpredictability, while cosmology seeks to map out the grand, ordered structure of the cosmos. Reconciling these two fields is like trying to fit together pieces of a puzzle that don't quite match. Think of it this way: if the universe is a giant jigsaw puzzle, dark matter might be one of those mysterious pieces that doesn't fit neatly into any of the existing sections. It's as if it belongs to a different puzzle altogether, one we haven't fully assembled yet. And that's where the quantum connection comes in. By exploring the possibility that dark matter operates on quantum principles, we might finally find the missing link that helps us complete the picture. But this is no easy task. It requires not only cutting-edge technology, but also a willingness to rethink some of our most fundamental assumptions about how the universe works. As we wrestle with this quantum conundrum, it's worth asking, could dark matter's quantum nature also hold clues about life beyond Earth? That's a question we'll explore next, as we dive into one of the most tantalizing riddles of all, dark matter's potential role in the search for extraterrestrial life. What if the search for extraterrestrial life isn't just about scanning the stars, but also about unlocking the secrets of the unseen? Could dark matter, this mysterious, invisible substance, hold the key to finding civilizations beyond our own? It's a tantalizing thought, and it leads us to the 16th riddle, the alien enigma. Imagine for a moment that advanced civilizations, far beyond our current understanding, have already mastered the art of detecting or even harnessing dark matter. What might that look like? Could dark matter act as a kind of cosmic energy source, powering their technologies in ways we can't yet fathom? Or perhaps it serves as a medium for communication, allowing civilizations separated by vast distances to exchange information instantaneously. Think of it like a cosmic treasure hunt, where the prize isn't gold or jewels but the very fabric of the universe itself. Every discovery about dark matter could bring us one step closer to answering the ultimate question: Are we alone? This riddle doesn't just challenge our understanding of the cosmos, it invites us to consider how dark matter might reshape our search for intelligent life. And as we ponder this, another question emerges. Could dark matter hold clues not just about life beyond Earth, but about the very nature of reality itself? What if everything we thought we knew about reality was just the tip of a vast, unseen iceberg? Dark matter, this mysterious substance that makes up most of the universe's mass, doesn't just challenge our scientific models, it forces us to question the very nature of existence itself. This brings us to the 17th riddle. Is dark matter a clue to the true nature of reality? It's a question that bridges the gap between science and philosophy, inviting us to explore what lies beyond the limits of human perception. From a scientific perspective, dark matter is a puzzle piece that doesn't fit neatly into our current understanding of the universe. It doesn't interact with light, yet it shapes galaxies and bends the fabric of space-time. But what if it's more than just an invisible force? What if it's a window into a deeper layer of reality, one we've yet to fully comprehend? Some theorists suggest that dark matter could be part of a hidden dimension, a shadow realm that exists alongside our own. This idea isn't just science fiction, it's a serious possibility that could redefine our understanding of space, time, and matter. Philosophers, on the other hand, might argue that dark matter serves as a cosmic mirror, reflecting the limitations of human knowledge. Just as a mirror shows only what's visible on the surface, our current tools and theories can only reveal so much about the universe. Dark matter reminds us that reality might be far stranger and more complex than we can imagine. It's a humbling thought, one that pushes us to ask bigger questions about existence, consciousness, and the nature of truth. The implications of this riddle are profound. If dark matter is a clue to a deeper reality, what does that mean for our place in the cosmos? Could it hint at new laws of physics waiting to be discovered, or does it suggest that reality itself is layered, with dark matter as just one thread in a much larger tapestry? These questions don't just belong to scientists in labs, they're questions we can all ponder, connecting us to the mysteries of the universe in a deeply personal way. As we peel back the layers of this riddle, we're left with one tantalizing thought. Dark matter might not just be a missing piece of the puzzle, it could be the key to unlocking an entirely new understanding of reality. And as we edge closer to solving this cosmic mystery, we're also drawing nearer to the next riddle, one that explores how dark matter might hold the secrets to discovering entirely new physics. The universe has always been full of mysteries, but dark matter might just be the most perplexing of them all. It doesn't just challenge our understanding of the cosmos, it outright defies the laws of physics as we know them. Here's the riddle. If dark matter doesn't interact with light, doesn't behave like ordinary matter, and yet makes up most of the universe's mass, what new laws of physics are we missing? This isn't just a gap in our knowledge, it's a glaring sign that our current understanding of the universe is incomplete. Some of the brightest minds in science believe dark matter might be the key to unlocking entirely new realms of physics. Imagine it as a cosmic puzzle piece, one that could fit into theories like quantum gravity or a unified field theory, the so-called theory of everything. These frameworks aim to explain how the universe works at both the smallest and largest scales, bridging the gap between quantum mechanics and general relativity. Dark matter, with its enigmatic properties, might just be the missing link that ties these ideas together. It's as if the universe handed us a key, and we're still figuring out which doors it can open. What's even more thrilling is the possibility that dark matter could revolutionize not just physics, but our entire understanding of reality. It could reveal forces, particles, or dimensions we've never even imagined. Think about it. Every major discovery in physics, from Newton's laws to Einstein's relativity, has reshaped how we see the world. Dark matter could be the next great leap, reshaping our cosmic perspective in ways we can't yet predict. And as we stand on the edge of this new frontier, we're left to wonder, could dark matter also hold clues to the origins of the universe itself? Picture the universe in its earliest moments, a seething, unimaginably hot soup of energy and particles, bursting into existence in what we call the Big Bang. From that explosive beginning, everything we know, stars, galaxies, and even the laws of physics, began to take shape. But hidden within this cosmic story is a mystery so profound it challenges our understanding of the universe itself, the origin of dark matter. How did this invisible, elusive substance come to be? Scientists have long puzzled over this question. One leading theory suggests that dark matter might be a thermal relic, a leftover from the early universe's extreme heat. Just as steam condenses into water droplets when it cools, particles in the early universe could have clumped together to form dark matter as the cosmos expanded and cooled. Another idea proposes that dark matter could be made up of exotic particles. Unlike anything we've ever detected, these particles might have been forged in the chaotic aftermath of the Big Bang, existing in a state we can't yet observe or understand. But here's the catch: pinning down dark matter's origins is no easy task. The universe's early moments are shrouded in mystery, and the conditions back then were so extreme that they defy even our most advanced simulations. It's like trying to piece together a cosmic birth certificate, a record of what happened billions of years ago, written in a language we're still learning to decode. Every clue we uncover, from the faint whispers of ancient light to the intricate dance of galaxies, brings us closer to understanding, but the full picture remains tantalizingly out of reach. As we continue to explore this riddle, we're not just uncovering the secrets of dark matter, we're also glimpsing the fundamental forces that shaped the universe. And that brings us to our next mystery. Could dark matter hold the key to unlocking one of the universe's deepest symmetries? The answer might lie in the delicate balance that governs everything from the tiniest particles to the grandest galaxies. Imagine the universe as a grand, intricate dance, where every particle, every force moves in perfect harmony. This harmony is rooted in symmetry, a fundamental principle that shapes the very laws of physics. From the way galaxies spin to the way particles interact, symmetry is the hidden choreographer behind the scenes. But here's the twist. What if dark matter is the missing dancer, the unseen partner that completes this cosmic ballet? This brings us to the 20th riddle, the Symmetry puzzle. At its core, it asks a profound question. Does dark matter hold the key to understanding the deeper symmetries of the universe? Scientists have long theorized that dark matter could be connected to supersymmetry, a concept in particle physics that suggests every known particle has a hidden, symmetrical counterpart. These counterparts, if they exist, might explain why dark matter is so elusive. It could be made up of particles that interact with our world only through gravity, remaining invisible to our detectors. Think of it like a cosmic balance scale. On one side, we have the ordinary matter we see and study: stars, planets, and galaxies. On the other side, hidden from view, lies dark matter, tipping the scales and holding everything together. If supersymmetry is real, it could reveal why this balance exists, unlocking secrets about the universe's structure and evolution. The implications are staggering. If dark matter is tied to supersymmetry, it could revolutionize our understanding of particle physics and cosmology. It might explain why the universe looks the way it does, why galaxies form the way they do, and even why life itself is possible. But as with all great riddles, the answers are still just beyond our reach. This leads us to the next mystery. Could dark matter also hold clues to cosmic anomalies, those strange, unexplained phenomena that defy our current understanding of physics? The journey continues as we step into the unknown, searching for answers in the shadows of the cosmos. Imagine gazing into the night sky and witnessing a sudden, brilliant flash of light that fades almost as quickly as it appeared. These fleeting cosmic events, like fast radio bursts or gamma-ray bursts, are some of the universe's most puzzling anomalies. They arrive without warning, leave behind little trace, and challenge everything we think we know about the cosmos. But here's the tantalizing question. Could dark matter be the key to unraveling these mysteries? Scientists have long speculated that dark matter might play a role in these enigmatic phenomena. Fast radio bursts, for instance, are incredibly powerful signals that travel across billions of light years, yet their origins remain shrouded in mystery. Some theories suggest that dark matter interactions, perhaps collisions between dark matter particles, could generate these bursts. Similarly, gamma-ray bursts, the most energetic explosions in the universe, might be influenced by the gravitational effects of dark matter or even the decay of exotic dark matter particles. But testing these ideas is no simple task. Dark matter, by its very nature, doesn't emit light or interact with electromagnetic forces, making it invisible to our telescopes. It's like trying to solve a cosmic detective story with only half the clues. We have to rely on indirect evidence, piecing together the puzzle through gravitational effects and the behavior of visible matter. This means that while the theories are fascinating, they're also incredibly difficult to prove. Think of it this way: if the universe is a grand mystery novel, dark matter is the elusive character who leaves behind just enough hints to keep us guessing. We know it's there, influencing the plot, but its true identity remains hidden. And as we explore these cosmic anomalies, we're reminded just how much we still have to learn about the universe and its hidden forces. But the mystery doesn't end here. As we edge closer to solving these riddles, we're also approaching the ultimate question: what is dark matter really? What secrets does it hold, and how will uncovering them reshape our understanding of the cosmos? The answers may lie just beyond the horizon of our current knowledge, waiting for the next breakthrough to bring them into the light. After unraveling 21 riddles about the invisible force shaping our universe, we've arrived at the ultimate question, the one that lingers in the minds of scientists and dreamers alike: what is dark matter? This isn't just a scientific query, it's a profound mystery that challenges our understanding of reality itself. Will we ever truly grasp the nature of this elusive substance, or is it destined to remain one of the cosmos' greatest enigmas? The pursuit of dark matter isn't just about filling in gaps in our knowledge. It's a journey that raises deeper questions about the limits of human understanding. Think of it like sailing across an endless ocean, where every discovery reveals new horizons but also more uncharted waters. Scientists have mapped the stars, measured the gravitational pull of galaxies, and even built detectors deep underground to catch a glimpse of dark matter particles. Yet the answers remain just out of reach, like a shadow slipping through our fingers. But here's the thing: every unanswered question is an invitation to explore further. The possibility of future breakthroughs keeps this cosmic journey alive. Imagine a day when we finally detect dark matter directly, or when a new theory reshapes everything we thought we knew. That's the beauty of science. It's a never-ending adventure, full of surprises and revelations. Reflecting on these 22 riddles, we've traveled through the strange and wondrous landscape of dark matter, from its gravitational fingerprints to its role in the universe's structure. Each riddle has been a stepping stone, bringing us closer to the heart of this mystery, even if we're not quite there yet. And perhaps that's the most exciting part, the journey itself, the questions we ask, and the stories we tell along the way. Because in the end, isn't that what science is all about, exploring the unknown, one riddle at a time? As we reach the end of this journey through the 22 galactic riddles of dark matter, it's worth taking a moment to reflect on just how far we've come and how much remains unknown. Dark matter, this invisible force that shapes the cosmos, continues to challenge our understanding of the universe. From its elusive nature to its role in the formation of galaxies, every discovery raises new questions, pushing the boundaries of human knowledge. Yet, despite its mysteries, scientists have made incredible strides in piecing together the puzzle, using cutting-edge technology and groundbreaking theories to shine a light on the unseen. These riddles aren't just scientific curiosities, they're windows into the very fabric of reality. They remind us that the universe is far more complex and wondrous than we can imagine. And while we may not have all the answers yet, the pursuit of understanding dark matter is a testament to our unyielding curiosity and determination to explore the unknown. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." That sentiment perfectly captures the spirit of this quest. Every riddle solved brings us closer to uncovering the secrets of dark matter, and with it, a deeper understanding of the cosmos itself. So, what do you think? Are these mysteries a sign of how much we've yet to learn, or are they clues waiting to be decoded? Let us know your thoughts in the comments below. If you've enjoyed this exploration into the mysteries of the universe, don't forget to subscribe for more deep dives into the cosmos. The universe is vast, and its greatest secrets are still waiting to be discovered. Together, let's keep exploring, questioning, and marveling at the wonders that lie beyond the stars.